Hello, this is our senior design project for industrial engineering at Iowa State University, fall 2019. Our project is a manufacturing flow problem. Our team members involved are Bradley Coleman, Devin DeYoung, and James Yap. For the problem, the team is working with a low volume, complex part with lots of variability due to repairs. These parts were not making their target lead time and were experiencing an increase in production. Additionally, there was a desire for an increase in the visibility for the parts on the floor. The team's overarching goal was to decrease the amount of WIP for this part by 10%. This was done by designing a visual dashboard that displays the progress of parts, a precedence system at the common process area to facilitate flow, and piloting live RFID tracking software to complement current tracking system. At the facility the team worked at, the milestone data for each step is collected by scanning a barcode after every test is completed. These are called confirmations. After speaking with technicians and analyzing the confirmation data, the team became aware of batch scanning, which is when several steps are completed, but the confirmation barcodes for those steps are scanned in batches. This can be seen when looking at the charts above. The average time for one step is very long, with the following steps all having close to zero time. The team has made recommendations to standardize the procedure so the future data will be accurate.
When looking into product flow, the team realized that parts were spending a long period of time at the BGA repair station. After analyzing defect data regarding the product our team is focused on, the team found that parts were arriving at the station at a faster rate than they were leaving. Both median and mean are shown due to the presence of outliers. The median arrival rate is about 1 unit per day, and the median time in station is about 6 days. When piloting the Wiser system, the team experienced lots of scattering when holding the tags at a reasonable height, which is the photo on the right, as opposed to holding them high in the air, which is the photo on the left. The team scheduled a meeting with Wiser representatives in order to solve this, and the problem was solved by recalibrating some of the antennas. This is a snapshot of the implemented Wiser system. Each of the colored zones is a defined area to historically track where the part has gone. Each dot on the map is an individual tag that's associated with the part. It's possible to watch the parts move in real time through the facility and even search for specific orders and have their locations displayed. These are the cards and precedence system for the BGA station that our team has come up with. Because the station experiences long wait times, the team designed 2 sets of cards for alternating weeks. This can be seen in the action in the figure above, as the Hash Monday cards are the older orders. We also wanted to standardize the way that incoming parts are placed in a rack in the station. The image on the right shows the way our team recommends the incoming parts should be organized so it is clear what the operator should work on next.
The Tableau dashboard uses data from the company's SAP system. A macro written by the team prepares the data to be read by the Tableau file. This dashboard shows the progress for parts through the system and can even be used on other product information pulled from the SAP system. Shown here is a like-for-like dashboard with the one designed, however with mock data. As you can see, the orders are sorted on the x-axis by the step they are currently in. From there, they are sorted by color by their age. It is possible to hover over these orders and see information regarding that specific part. The information included is the order age, the order number, the serial number for the part, and who confirmed the part last. There's more information accessible in the Full Data tab. You can see the time and the date that the part entered that step. There are 2 separate dashboards included. The first one is the last time that the SAP data was updated. This is just so whoever is using the dashboard can get an idea on how recent the information is. The other dashboard is a weekly review dashboard that displays the parts that went out the door during the last 7 days. This is to be used during the weekly cadence meetings held, as the dashboard will display the performance of the prior week and how many orders are making it out on time. One of the problems expressed to the team was that it can sometimes take a significant amount of time to track down specific parts in the facility. This dashboard displays information important in aiding to track down parts and provides an overview of the entire process. The return on investment was calculated based on the carrying cost for the part, the amount of lead time saved, and the working days per month. This was compared to the costs associated with this project: engineers' time, travel costs, the initial Wiser equipment cost, cards for the BGA station, and finally, the payment to Iowa State from the company. The time it would take for these costs to equal each other is 6 weeks. In conclusion, the team designed a dashboard that can be applied to different products from the company, piloted Wiser live RFID tracking software in a real manufacturing environment, designed a precedent system at the BGA station, and identified batch scanning and the problems it causes.